Hey, I see a few messages that have come in. Let me just read out a few introductions in a while. Hi, Daniel. Thank you for joining us from Kenya. Hi, there's someone from Virginia, but I don't have your name. Swati, thank you for joining us. Hi, there's a Syed. Someone, Anthony, I think, from Chicago. Hi, Fred from Philippines. Hi, Swati. Thank you for joining us. Hi, Akhilesh from Mumbai, Aarti from, okay, we don't have that detail. Hi, Rutvi from India. Hi, Radhika from India. Abhilash from India. Dr. Thomas from Nigeria. Great, amazing, amazing. A lot more introductions. Sorry, I'm unable to read um, every every single introduction, but super, super great to have you all here. We are also live on LinkedIn and YouTube, and we have more participants watching us from all over the world today. So, really excited to get started. Let me quickly introduce myself. My name is Ananya. I would be hosting the session on behalf of Simplilearn. This is the rise of SLMs, what ML and data professionals need to know now. We're here to talk about something that's quietly becoming one of the most important conversations in the AI space right now, small language models or SLMs. And trust me, by the end of today's session, you'll walk away with a very different way of thinking about how AI actually gets deployed in the real world. And before we kick off, a quick note, this webinar is being brought to you by Simplilearn in partnership with one of the world's leading engineering institutions, which is Michigan Engineering Professional Education from the University of Michigan. We have a fantastic expert also with us today, and we're going to have a really rich conversation. So let's get started. Okay, just a few quick ground rules before we dive in. If you have any question, and we really hope that you do, please drop them in the Q&A box. That's the best way to make sure that we catch them, because as you can see, the number of pings that keep coming are a lot, so we might end up missing an important question in the chat box. Whereas you can use the chat box, but please keep it for general conversation relevant to the topic. Please do not share any personal details or irrelevant details. This will be monitored very closely and deleted if there is anything inappropriate. And very importantly, if you would like an attendance certificate for today or the recording of the webinar, please make sure to enter your full name in the poll that we'll launch at the end of the session. We will not be able to take any manual entries, manual submissions for the recording or the certificate. So please do stay tuned with us till the end. How long? This is a question regarding how long the session will be. It will be a 1 hour session, and we hope to wrap up within time. And like I said, the recording will be available for all of you who participate in the poll and give us your full name. Okay, so a quick poll. Is there anyone else, anyone in the audience who has attended Simplilearn webinar before? I think like I've seen some of you in our previous sessions as well. But if it's your first time here, please just type first time and let us know in the chat box. Chat box. Okay, I'll just wait a moment for more responses to come in. Okay, wow. Great. First time, first time, first time. A lot of first timers here. Very, very great. Okay, so for those of you who are joining us for the first time, let me give you a very, very quick sense of who we are. Simplilearn is a global digital skills platform with a very simple mission, that is to transform lives by helping people build the skills that really matter in today's world. We have helped advance the careers of over 15 million people across 150 plus countries, and we work with 50 plus global partners to make that happen. We are consistently ranked among the top training companies in the world, and we're proud of the fact that our learners and graduates rate us really highly. So you are in great hands today as well. A big part of what makes Simplilearn's program stand out is who we work with. Our partner ecosystem spans some of the most respected universities and companies in the world across the US, India, and globally. These aren't just, logos on a slide. They're active collaborations who help shape our curriculum, provide industry exposure, and lend real credibility to the credentials our learners earn from our programs. We'll come back to this context when we talk about the program later. For now, let's focus on why you're all here today. And before we jump into the content, I just want to give you a quick snapshot of what makes Simplilearn programs different because it's relevant to what we will share later. An 80% graduation rate and a 4.8 out of 5 rating. These are numbers that reflect a learning experience that's very practical, that's live and very deeply relevant to what the industry demands currently. Our programs are co-created with industry partners, like I mentioned, and taught by practitioners and not just academicians. So what you would be building is real world skills and not just theoretical knowledge. Right. Okay. So moving on, here's a quick look at what we are going to cover today. We are going to move through this as a conversation and not a lecture. So it should be very, engaging for everyone here. We will start by asking, a simple but uncomfortable question, maybe, which is the AI your organization is using actually costing you more than it should? Then we'll get into what SLMs actually are, why enterprises are shifting towards them, how they are being used in the real world, how to choose between an SLM and an LLM, and what all of this means for your career and your role and your future in AI. So, the last part of today is particularly important for anyone thinking about where the AI space is heading and what skills you need in order to stay relevant in the coming years. So, please do stick around for that. Okay, so let me now bring in our expert for today. I'm really, really looking forward to hosting this session with him. Kennedy is a senior AI/ML engineer with a very rich background spanning data science, machine learning, and data engineering. He's worked with some of the most well-known names in the tech space, including Amazon Web Services, and currently works at Cloudpiece, where he continues to build and deploy scalable machine learning systems. His expertise span generative AI, ML ops, deep learning, reinforcement learning, and more. And he brings real production experience to everything that he talks about. So the insights you're going to hear today, will go well beyond theory. They're because they're directly from someone who's actually built these systems. Kennedy, a very very warm welcome to you. Great to have you with us. Over to you for a quick hello before we kick off, and then we'll get into the content.
Yeah, thank you. And thank you for the good introduction and welcome everyone to this session. I do see, I was looking at the chat here and I do see we got people joining from different parts of the world. I think some places it is even night. So thank you for finding time to join. And I look forward to be part of this conversation that we're going to have here today regarding the small language models. My background, I think a lot have already been mentioned. So currently I have about more than 8 years of experience in the industry around machine learning, artificial intelligence, deep learning, ML ops, and I'll be happy to have more discussion about that as we continue with the webinar. Back to you.
Perfect. Thank you so much, Kennedy. It's amazing to have you here. Okay, so we will get right into the first segment. Before we talk about the world of SLMs, I think it's important to sort of set the stage for this topic. A lot of organizations these days are using AI very, very prominently, like ChatGPT, GPT-4, various cloud-based models have become common and part of our everyday lives. On the surface, it seems like everything's working. Everyone is in the AI adoption mode, and it's like interesting and exciting to try new models, new tools, etc. But I want to ask you, is there actually a problem here that people are not talking about enough, particularly when it comes to the reality of what AI is costing us?
Yeah, good question. So first of all, when it comes to the deployment of this large language model or AI application in the real world for your production environment, there are a lot of factors that you have to take into account. And you're thinking about the resources, the deployment resources that you'll need to deploy this. Hence, as a result, there are instances where using a large language model might not be the right kind of tool that you do need, but you could use even a small language model. with understanding what exactly is a small language model. Let's take a step back and understand what is a small language model, and then now contextualize it to the question that you've asked. Now, a small language model is basically a model that is trained on either fine-tuned or trained on very few parameters, and also for a very specific use case. There are different strategies of taking maybe like already existing large language model, then the different strategies to make it smaller by fine-tuning it on very specific use cases, domain-specific use case. So you could have maybe a large language model, maybe you have quantized it through the process of quantization, or maybe you have like distill it through the process of distillation that allows you to have a smaller model, which is capable. So back to the question in terms of the costing itself. So yes, large language model in general, in terms of the token, more so if you pick like, let's pick like the most, the very current up-to-date ones, like whether that is OPAS 4.6 or this large language models, right? So their cost in terms of the token uses are usually like really very high comparatively. So if your specific use case does not require a large language model, then a small language model will suffice. And again, as we're going to have this discussion, we are going to look at what are some of the instances, the factors that you need to take into account when it comes to choosing, do I need to use a large language model or maybe use like a small language model? I think you're muted. You're muted?
Yes, my apologies. Thank you. So I'm just going to keep myself on mute so that there isn't an echo. Yeah. So thank you for drawing the comparison, Kennedy. I think that sets the perfect context. And my next question was actually about, it was going to ask you to explain how, what SLM is all about. So I'll move on to the next slide. If there's anything that that we need to deep dive into from this slide, then you can take it up. Maybe the use cases of small language models.
Yeah, exactly. So let's take a quick comparison of SLM, looking at the slides here. Let's take a quick comparison of the SLM and large language model. So what makes a language model to be called small? So first of all, this is the model size itself, right? So when it comes to the model size for small language model, they do use fewer parameters compared to large language model. The hardware needs, they need low hardware needs in terms of for you to be able to operationalize them. In terms of the latency, small language models are comparatively faster. The different versions or varieties of small language model, then those come with specific latencies in terms of the use case itself. The cost, comparatively, they are also less costly if you compare that with the large language model. So, and I think I've already addressed briefly what makes a large language, a model to be referred to as a small language model. And what I want to talk about is, as you can see there, so we talk about the parameter count, that's one. And also when it comes to the task itself. So small language models are very task specific. You could take your large language model, for example, you could fine tune it and make it for a specific use. What do I mean by this? So say you got like a foundation model. What is a foundation model? Well, a foundation model are this large language model that are trained for, I would say, general purpose. So you could refer to them as their general purpose kind of models, large language model. You could take that foundation model, then you can be able to undergo, maybe perform some kind of fine tuning to it, or maybe do some kind of quantization or distillation to it. Then you come out with a small language model that is very task specific. So you train it on a very specific task, then that is what you use it for. And when we talk about edge readiness, now to be able to deploy a large language model on edge, say like on device, I believe we all have like smartphones. So say you got like your iPhone 17 Pro or your Samsung Galaxies and all that, right? And you want to deploy like LLM to that device to be able to deploy a large language model on device is going to be really challenging in itself because you need to take account of all these different factors like the hardware need, the latency, and all that. So the small language model, one of the advantage that it comes with is that due to the comparatively low hardware needs requirements, you can be able to deploy a small language model like on device, for example, on like your phone. Another advantage with the small language model, because of the small size, because of the latency, the cost that is involved, you could be able to easily deploy this within your own, manage this and deploy it within your own environment without necessarily having to rely on like the cloud itself, using the cloud deployment, because you could run it on your own hardware on premise or maybe within your own enterprise infrastructure. Then those are some of the factors that make a small language model more I guess more desirable, or when it comes more relevant for some specific use case when you need to think about like data privacy and etc.
Okay, thank you, Kennedy. There is a question from Ramesh about the combination of multiple SLMs used as alternative of LLM. Actually, we will be covering this in one of the upcoming slides. So, Ramesh, I hope you can stay tuned for an answer to that question. Kennedy, maybe you can take the other question that's come from Aryan Khan.
Okay.
What are the primary architectural differences between an SLM and an LLM, the primary architectural differences?
Yeah, so in terms of, let's talk about first of all the large language model. A lot of majority of the large language models actually are transformer based, but a little bit of I would say different flavors in terms of how the implementation of the original transformer based, which came out in 2017 from the Attention is All You Need paper. So talk about like if we talk about some of the most frontier large language model out there within the market, we got like maybe Kimi 2, we got different ones, right? We got DeepSeek. Originally, they all use and they are based on the transform architecture, but are different in terms of the implementation of the transform architecture itself. Now, back to your question regarding what is the difference between the small and large language model. So the key difference here is that with small language model, let's say you got most of the large language model are trained on the 32 floating point precision. So if you take like a 32 floating point precision model that is trained on that, then what you could do is that you can quantize it to a lower precision, which could be maybe int 8 or int 4. The difference here is that for the quantized model, that you made it smaller by just reducing the precision of the model weights itself. So the underlying architecture itself is not so much of the bigger difference, but the big difference here is just the precision on how you quantize it and reduce it to a smaller precision representation of it.
Perfect. Thank you for answering that. Moving on. So, all of this is very fascinating. We've talked about what SLMs are in theory, but what does it actually look like when a company puts one to work? I think a lot of people also might be wondering in the audiences, hey, this sounds great, but is this actually being used, or is it mostly still a conceptual thing that's being researched? Like, what's the reality of it in ground when it comes to production?
Yeah, good question. So it doesn't mean that actually small language models are replacing or companies are not using large language model. But again, there are several factors that you have to take into account when you want to productionize your, agentic or LLM applications. One of those could be you need to think about the ROI, the return on the investment. Now, companies are using both an hybrid approach to it, where you use large language model for specific use cases and you use small language model for specific use cases. And is this something that is already, is this like a theory? No, it's not a theory. I mean, this is something that already takes place within within different industries in terms of what is being used. And if you can see here from your slide, I cannot go through all of them, but you can see here from the slide itself in terms of the different use cases where maybe you got something like Llama 3.3 Llama 7 billion parameters where it is being used. Maybe like Gwen, for example, where it is being used in terms of the customer support use cases. So yes, small language model are being used in the industry, but not as a replacement of large language model, but rather as an hybrid for the augmentation, depending on just your specific use case. And I'm happy to
Okay.
take any question anyone is having to dive a little bit deeper on that.
Okay. Okay, so we'll wait for some questions to come in. Meanwhile, I'll move on to the next slide. So, what are some factors actually pushing organizations and enterprises, towards the shift? Like, what are the main reasons why people are slowly navigating towards SLMs?
Yeah, so on top of mind here, the ROI to start with, let's start with that. So the cost itself, because using large language model, imagine you are, let's take a very simple example. Maybe you are building like HR kind of an application, HR assistant that leverages AI in the backend to be able to respond to your HR related questions, right? So maybe you are building something like you got like a RAG system that in the backend that you are leveraging, you got your internal documentation, HR policies, and all that relevant to your enterprise itself. It does not perhaps makes a lot of sense to be able to take the most expensive large language model out there just because it is fast to be able to use it for that specific use case itself. So the cost is driving this, whereby instead of using a very expensive large language model, but while actually the task that you need to perform does not warranty such kind of, the power that comes with the large language model, you could use just a SLM as well to be able to achieve the same task. So cost is one. So just swapping, looking at where exactly would a large language model make sense for me in terms of my business requirement and where would I use a small language model. Another one again is when it comes to data privacy. We've talked about one of the challenge or one of the key concerns that a lot of enterprises do have when it comes to using AI is security, data privacy. Because the first question an enterprise will ask is, where is this data going to go? Who got access to this data? Whether I'm using whichever any of the large language provider, are they going to have access to my enterprise data, right? So those are concerns that a lot of enterprises do have. But in the case of a small language model, as we have mentioned in terms of even the hardware requirements and all that, you could be able to actually run this on-prem within your own internal infrastructure, hence addresses the question of the data privacy. Another reason is also when it comes to the latency. Comparatively, because of their small sizes, most large language model as well, if you compare to large language model, I've got really also lower, the latency that for you to be able to inference time. That is not taking into account the infrastructure that you're running them on, but comparatively, they are much more faster when it comes to maybe for your inference time. So that is another thing that is driving enterprises in using the small language model. And then also lastly, task specific. So as we have mentioned at the beginning, we talked about that small language model are really task specific in terms of your fine tuning. You can fine tune them for specific task itself. Then that makes them more powerful. Instead of using just a general language model, then you use the one that is fit for the specific task or the job that you need it for.
Great, thank you so much, Kennedy. I see a lot of questions that have come about how do we decide whether to use SLM or LLM, and about hybrid use. We will be covering that in the future slides, so please do stay tuned. But one question I think we can take now, Kennedy, is just let me put that. Okay, what are, like, can you give us maybe a couple of examples or like real life applications of SLMs? Like, so if I have to start using SLMs from tomorrow, like where can I apply them?
Yeah, so SLM really got really wide. application, real world application where you could use them. It just depends on what exactly is it that you're doing. So let's take a very simple example, maybe something that all of us we do have. We do have like phones, right? Um, for your smartphone. With a smartphone, majority of this smartphone these days got like some kind of AI capabilities. Uh, what are they using there is a small language model that perhaps is within on-device small language model that are being used. That is a very practical examples that maybe you already have a phone which is already using AI. When it comes to different, like for enterprises, depending on which vertical or whatever it is that you're doing as an enterprise, I'm very sure there are use cases that, let's say, even for document processing itself. I've talked about building something like a chatbot for your AI assistant, maybe for your HR or whichever you're using for your enterprise. Using like a small language model there would be able to suffice because you could take a small language model that is trained on maybe question and answering, and you also fine tune it on your enterprise specific data. And that can allow you to be able to use a really very focused small language model instead of taking like a large language model that perhaps is not very focused to your specific use cases.
Yeah, perfect, perfect. Thank you. So, I think that perfectly sets context, for the next segment, and rounds up the first, segment that we just discussed about. And this is quite a powerful statement that we have here. Most production AI tasks do not need GPT-4. They need a precise, fast, cheap model that does one thing brilliantly. Kennedy, I think there might be like, sort of fear in the industry that if you use small language model, you are probably somewhere settling or compromising on the quality. Is that true? Like how do you tackle such a dilemma?
Can you repeat that again regarding the quality? Sorry.
Yeah, so like, is there what would you like to say to people who think that if you're using the smaller language model, which is cheaper, you might be compromising on the quality of the output? So is that the case? Is there a difference in terms of the quality of the output?
Yeah, so I won't say it's about compromising on the quality, just like I mentioned. Each of these different type of models do got their own specific, would I say, what they are good at. If you got a task that perhaps require general kind of reasoning, then if you take like a small language model and a large language model, then a large language model is stronger when it comes to general kind of reasoning itself. If you want to think about also in terms of just the domain specialization, then a smaller language model will excel in the domain specialization as compared to, with a large language model. So it is not about compromising on the quality, but rather choosing the right tool for the right job. So if your task specific is something which is general reasoning for your specific enterprise use case, then you don't want perhaps to pick a small language model for that. You go for a large language model. So it is a question of hybrid use of it. You pick the right tool for the right job.
Okay, great, perfect. And that's what we're going to discuss about next. So SLM versus LLM, if you have to like, put them head on, how should people actually be thinking about this choice? Can you give us a framework for making the language model decision?
Yeah. So I think when we're starting this conversation, I mentioned that whenever you want to make a choice between what factors do you need to take into account when choosing either to go for a large language model or a small language model for your specific use case. So number one, first of all, you have to really define what exactly is the task that you want to achieve. What exactly do you want to achieve with your application? So if your task is something that is well-defined, well-scoped, well-structured, then you'll take a look at SLM and LLM. And as I mentioned, LLMs are good for general purpose kind of reasoning. But if your task is something that is very specific and well-defined, then you'll go for SLM instead of LLM. because you don't need all that power that comes with the large language model just to be able to perform, or rather to perform a task that that's already well defined in itself. Number two, if you think about in terms of the latency, let's say for your specific application, and then again, I'm not trying to like generalize here, because when you are a specific application, depending on like what you're trying to build, requires a really faster latency, then a small language model would be a better candidate comparatively to a large language model. And again, here, remember, when we talk about small language model and a large language model, they are different, would I say, in terms of versions, I would say that, of small language model. There's small language model that have maybe 128K token, and there's one that are fewer less than that. But again, so in general, when we make the comparison, then you find that if you were to take a small language model and a large language model, generally you'd get low latency when you are using a small language model. The data privacy is of a key concern. We talked about this. And the main reason why, when it comes to data privacy, more so for the industries that are, regulated industries that requires a lot of compliance and regulations around them in terms of how you conduct your business, then small language model here helps in addressing that, in the sense that if you're really not deploying your model in the cloud somewhere, if your data is not getting outside your infrastructure itself, then that gives you some kind of comfort in terms of the security of your data. That is where a small language model will also be will be a good candidate for it. The budget itself, the cost. So with the cost, large language model requires a lot of infrastructure setup, their hardware to be able to run them. You're going to run these GPUs that you do need, these accelerators, to be able to run this large language model. Comparatively, the infrastructure needs for small language model is less compared to large language model. The infrastructure needs drives cost as well. That is why you do see a lot of these data centers everywhere, because the more companies they need to leverage and use this large language model, the more the compute resource that is needed. Those compute resources come at a cost. So it means then, if your application requires you to use a lot of compute resources, then you're going to be paying more. Then as a result of paying that more, will lead it to the higher cost of operationalizing your application. Then also, when it comes to the creativity itself. So I've talked about general reasoning. So if you need something, your application requires general reasoning, be able to have the ability to be more creative, then we know that small language models are a little bit more scope for specific use cases. Then in that case, perhaps the best candidate will be a large language model. We have a lot of questions on the chat as well. Yeah, I think you can be able to pick some of them
Yeah.
as we go, but there are a lot of questions.
Yes, Kennedy, we have a lot of questions, and I think everybody, so we have a lot of people also here, and everyone has different use cases. They're from different industries, different companies. So, see, we're not here to, this webinar is not about telling you that use SLM for this task or use LLM for this task. What we're trying to do is just giving you, is to give you a framework which you can apply to make that decision, based on your requirement, based on your environment, right? So I don't think we will be able to specifically tell you that for this task use SLM, for this task use LLM, because we would need a lot of context before making such suggestions. So I'm going to skip those questions, but I think maybe one question that struck me was about data. I see a few questions about data. So how much data can SLM handle? Like, if you have to compare it with LLM, like how does that span?
Yeah, so again, like you mentioned, in order to be able to solution and recommend in terms of which path and what to take, we would need additional more context than just saying maybe you need X amount of data for maybe to a small language model and you need X amount for large language model. Remember, we got large language models, small language model that are like in terms of the context length itself around 128K and all that. So it doesn't mean there are a lot of nuances, there are factors that have to be taken into account to be able to say this is the amount of data that you need. But in general, when you look at small language model and in terms of the infrastructure, the resource need, then in general, they require less amount of course, if you're doing like some fine tuning. So in this case, I'm not sure whether your question is related to the data you need in order to fine tune a small language model, let's say, I mean, to get a small language model, or the data you need when you're already running it for inference. So in this case, I'm assuming if it is the data you need to maybe like fine tune, take a large language model and quantize it, I mean, fine tune it or whatever it is that you're doing to a very task specific one, then that is a very comparative question as well. That is hard to just put a number on it that you need this X amount of data. But for fine tuning, yes, you need comparative less amount of data as compared to training or pre-training a large language model from scratch. So you need comparative less amount of data.
Okay. I think it was about how much of company data can an SLM handle? Is there a fixed data set size limit, or does it depend on token limit, training method, and rack setup?
Actually, it depends on all those factors. So that's why when you want to, again, when you talk about company data, I believe a company, you've got a lot of different data sources, and I'm very sure not you don't need all of these different data sources would be used for just one specific business use case. You got a lot of different data sources. You're not going to build a single model based on all these different data sources. Perhaps you'd have data sources, but again, when you want now to build an application, there's some subset of data that can be used for X application, another one for Y application, another one for A and B, C, different application itself. So that also will depend. There are factors that you have to take into account there.
Okay, perfect. So moving on, I think this is the topic that a lot of people will be interested to know a bit more
Mhm.
about.
Mhm.
So how does the hybrid model work? Like, can you take us through the hybrid setup, and what it actually looks like in practice, and how to actually achieve that middle ground between balancing the models.
Yeah, so let me give you like a practical example. Say maybe you got like an application which you again, in production environment, when you're building an application, you want to have a way of smart routing of your task to specific model. So let's say you got an application that is, without going to any specific, maybe like you're processing some kind of, your questions are coming. So the task that is coming, when the task come, it hits your infrastructure. When it hits the infrastructure, the application itself, your LLM application infrastructure, let's say if a task requires not a lot of reasoning, it's not a very complex task. It's like a simple question and answering task that does not require deeper reasoning. You'd route that to like a small language model to be able to perform that task. If a task that is coming from the user requires more kind of a deeper reasoning, that requires maybe deeper thinking, then in that case, you route it to a large language model. So you have that smart routing, or where depending on the task that coming from the user, you route it to the right kind of large language, I mean, either small language model or a large language model. In that case, we talk about smart task routing. And so we talked about like when you want to use this, a decision whether to use a small language model or a large language model. We mentioned that it's not a question of a replacement, but rather picking the right tool for the right task itself. Hence the need to have this hybrid where you got this kind of smart routing, where this semantic routing, where you could route it to the a task to the large language model or a small language model that is relevant for it. The cost itself. So we talked about in terms of for the cost optimization, we talked about when you want to, one of the advantage of using a smaller language model is that they take less infrastructure. They require less infrastructure to be able to operationalize and run them. So they help with the cost optimization. So when you take this hybrid approach, where for a simple task, you route to like a SLM. For a more complex task that requires broader reasoning, you route it to a large language model. That in itself helps you in addressing the need of the cost optimization here because you are not deploying all the time a large language model even for a simpler task. Then as a result of that, that is going to reduce the pressure on your infrastructure needs itself. As a result of that, which will optimally now help in addressing the cost that comes with running your application. We talked about also the latency in itself. So depending on your application, and again, here we are talking from a very general perspective, but again, for your each and every specific use case as an enterprise, there are factors that you need to take into account. But for a general perspective of it, when you talk about the latency, so a task that perhaps require very defined, well-defined task, once you route that to a small language model, then it means with the latency that's going to come with it, that's going to be a very faster inference time or response that you're going to get out of that. That will also reduce the general latency of your system. So say if your system, you got a system of small language model and large language model within your application itself. So if the compounded latency will be much more less, if, for example, for the specific cases where your application need a small language model, you routed it to a small language model, it means you're going to get the response much more faster. And we talked about also when it comes to the privacy itself. So using a small language model, which will allow you maybe to not really deploy anything within your cloud or your application within the cloud itself, but you can run it locally, will help you in addressing the privacy issues that comes with that. Hence, that is in terms of your data privacy, the data security, you can help you in addressing such kind of needs. So say like, for example, like I mentioned at enterprise, you will have different variety of data coming from different sources. Perhaps you got data that you need to process, but again, this data contains maybe a PII, personal identifiable information, or it is some sensitive data that you don't want to expose it. But again, still, you need to use it for your application. In that case, you could be able to, number one, you still have to do the regular steps or whatever you need to do to whether it is data anonymization or masking that you need to do to this data. But again, instead of exposing it to a large language model, you could be able to use, for that specific use case, use like a small language model for it.
Okay,
I hope that addresses the question. I'm not sure if, yeah, we have so
yes,
many questions on the
yeah.
chat.
Yes, yes, and we will get to questions in a short while. So I'm moving on to this segment. Let's like zoom out a little bit from the technology for a moment and talk about people and careers because of because all of this, the shift to SLMs, the new pipelines, the hybrid architectures, it might be changing what AI and data roles actually look like day to day, right? So from your perspective on the ground, how are you seeing the industry or how are you seeing roles change?
Yeah, good question. So, as all of us, we are in this field, I think this is maybe something that you are already experiencing. The industry is very dynamic. It's really moving very fast in terms of the innovation, in terms of just the new approaches, technologies on how to be able to perform certain specific tasks. So the industry is very dynamic and it's moving very fast. And that by itself comes with even the role shifting in terms of what exactly is expected from you as let's say, as machine learning engineer, AI engineer, or maybe a data scientist. So when we talk about, let's pick a role like machine learning engineer. So with machine learning engineer, before the rise of, adoption of wide adoption of AI in itself, for a machine learning engineer, you'd be expected in most cases to build your classic, let me call them classic or traditional machine learning model. You build your XGBoost application or whichever your neural network application, right? You'll have to think about I get my data, I do my data pre-processing, I train my model, I test it, deploy it, and monitoring, going through all that ML of life cycle. But again, right now, you see that as an ML engineer, and if you're an ML engineer, most probably, yes, there are instances that perhaps you need to build a classic machine learning model. But in most cases, you realize instead of now building the model from scratch, you are going to be leveraging like a large language model, for example, or building an agentic application in itself. That requires a different mindset and a different shift in how you approach the work itself. Because originally you'll have to train the model. In this case, in most cases, you are not even going to be training the model, but rather you are either going to be doing something like, either fine tuning, which is a little bit, in most cases, perhaps in overkill, or maybe using something like RAG. So you have to think about, I'm not training a model from scratch, but I'm taking already an existing model, but I'm doing some kind of an augmentation to it, which could be, you think about the prompt engineering. So as an ML engineer, you need to understand exactly what are the fundamentals? How do I do my prompt engineering? How do I think about in order to use an existing large language model, whether that is a GPT or Opus or whichever the model or the Gemini, which is there, how do I take this model now and build application out of it? So out of that, you see that you are not going to be doing training as perhaps you do in traditional approach to it, but rather you'll be taking an existing model and either augmenting using something like maybe RAG application to start with and doing some kind of maybe a hybrid of RAG, you do prompt engineering, maybe do something like fine tuning to be able to do that. When it comes to the, how even you want to approach your deployment, right? So in most cases, if you're using an existing, let's say large language model, you are using Anthropic or you're using Gemini, you're going to be dealing with APIs, right? So you're going to be calling the APIs that you need to call these different APIs in order to be able to work with these models and deploy them. So that is on the ML engineer. And again, the gap in terms of these different roles, this seem to be really the gap is like coming sort of like instead of becoming wide, becoming very small in terms of what is expected of you. Because as a data scientist, before you'd have to think about, okay, I have to get my model, do the training and all this. And if you're a data scientist that perhaps you are able to deploy the model, maybe you are doing both the training and deploying experimentation and deploying of the model in production as well. But again, in this case here, you realize that your work is not necessarily now more to do with experimenting with building models, because you build, experiment, you have different versions of the model, you check which one is doing well, then out of that, maybe you put it in production or work with your ML engineers or your DevOps engineers to help you put it in production. But in this case now, you realize that your work is, you're not doing that, but more you think about, I have this different large language model. How do I look? How do I now work with the existing large language model? Which model do I need for what specific task? So your all things now changes to thinking about what kind of model, whether is good for what specific use case. So your experimentation is not about training the model, but rather experimentation based on different benchmarks that you care about for your specific business use case. So you take a look at which model. I need a model for text generation, or do I need multimodal model? Or I need a model for maybe video. I need a model for maybe language generation. So you have now to think about which specific model do I need for which specific use case? And then you start doing your evaluation based on your specific benchmarks that you care about for your business use case. And that goes also for like when we think about role like AI ML engineer. You think about more on how, as you've noticed in the industry, when it comes to even doing like coding and all that, a lot of this AI assistant coding, whether it is Cloud Code, Opus, Cloud Code or Casa or Gemini, a lot of these different AI assistant tools are really becoming very good when it comes to writing code. Now, so the question is not necessarily that you need to spend a lot of time writing your code. You could be able to leverage this kind of AI assistant to write code for you, but again, you still need to have the responsibility of reviewing the code, making sure that it is the right code. But the question now is the operationalization itself. How do you now take design a system? So you are all shift more to thinking about the system design. How do you design a system that can be able to operationalize this different large language model or an hybrid of large language, small language model application that you're building? So thinking about the framework, when do I need to use what in order to build or architect and design this kind of a solution?
Okay, thank you for painting that very detailed picture. I think it sets the perfect context to understand how SLMs are changing the picture right now. Yes, we have a very striking data point here. Only 11% of ML practitioners have hands-on SLM fine-tuning or deployment experience, but 68% of companies plan to deploy edge SLM solutions in 2026. So that gap between the number of people who have hands-on SLM experience and the number of companies looking for it, that's a massive opportunity, right? So if someone wanted to start closing that skill gap for themselves, what's the most practical first step they could take this week, Kennedy?
Yeah, there are different ways or routes that one could take in order to be able to find yourself in that competitive, would I say, spot or advantage. The industry is moving fast, as I've mentioned previously, and it needs you to really to be up to date with exactly what is going on within the industry. But at the same time, look at when we think about the needs of the industry in order to now, we briefly talked about how the roles are shifting, where actually the roles are also coming kind of converging in terms of what a data scientist would do, what a machine learning engineer would do, what AI engineer would do. They're also really converging in terms of the different task or specific responsibility that you need to take depending on any of these roles that we talked about. So yeah, the question here is, how do you really position yourself to be in that spot where you have that competitive advantage, having the right skill to allow you to know, let's say, given given a large language model or a small language model, how do you really take it and customize it for your specific use case? So there are a lot of large language models or LLM out there. So how do you take one? How do you decide which is the right one that you need to take for your specific use case? And if so, what do you need to do to it? Does it require some kind of augmentation, customization that you need to do it? What exactly does that look like? So able to gaining such kind of scale, I believe puts you in a more competitive sort of like spot that allows you to be able to take this language model and operationalize it. And that also goes with, you need to think about, when you're talking about the operationalizing of these models itself, you need to think from the system design perspective of it. How do you take a system and design it and make it work? So those different angles, I believe, again, I'm not saying this is the only thing that you need to do, but those different angles really help in putting you in that position, a more competitive position to be able to address the challenges that comes with productionizing and using these LLM applications.
Okay, perfect. I think you spoke about staying updated and staying ahead with certain trends and skills that are arising, and that sets the perfect context for the next segment that we want to talk about. I think everything that we covered today shows the pace at which everything is changing. right? It's just extraordinary. SLMs didn't exist as a mainstream concept a few years ago, and now they're reshaping enterprise budgets, job titles, and how teams are built. So the question I want to leave with the audience is this: given that pace, how do you stay ahead of it? Learning on the job only gets you so far. So at some point, you need structured, comprehensive exposure, and that's exactly what we want to share with you next. Right. So what we are about to talk about is something Simplilearn is built specifically for this moment for professionals like you who want to go beyond the surface level and actually build expertise in AI and ML. This is the professional certificate in AI and machine learning delivered in partnership with Michigan Engineering Professional Education, one of the most respected names in enterprise technology. And let me tell you what makes this program very different from anything else out there. First, the certificate you earn comes from one of the world's most recognized engineering institutions, and that carries a real weight. Secondly, this is learning by doing. You will be building chatbots, working through AI automation challenges, and solving real problems. And third, you get IBM's direct involvement because this program is in collaboration with IBM. So certificates, master classes, and access to IBM experts. And finally, you walk out knowing 15 plus tools that are actually used in industry today. And yes, so where does this program actually start and how deep does it go? Kennedy, it will be great if you can take us quickly through the learning path of this program. Since you are, one of our mentors of the program, I think you'll be perfect to take the participants through this.
Yes, and I think this question, there is also a question on the chat that I was looking at here, which is, do I need to know Python for any ML language? Yeah, so I think that I'll address that question in the learning path here. So apart from my regular what I do in the industry, I'm one of the trainers here, and I teach one of the programs that I teach is the Michigan Professional, which is an advanced generative AI application here at Simplilearn. Those are weekend classes and evening classes. So in simple terms, they give you that flexibility to be able to even if you're working in the evening, you can take the class or take the class over the weekend. Now, the learning path there, if we take the one like, for example, the Simplilearn Michigan collaboration here for the advanced generative AI application, what we cover in the class, we start with like Python refresher. And that will address the question which I believe someone is having on the chat. So, yes. So when it comes to machine learning, data science, AI, Python is a predominant language that is used in the field. And the reason is that Python comes with a lot of advantages that makes it more relevant or more desirable to be used in AI or machine learning. It comes with a lot of libraries and packages that just makes your life much more easy to be able to use it for machine learning. So yes, you need to be able to have some level of knowledge in Python. And we recognize that most of the learners that join this program perhaps do not come from Python background. Maybe they come from another programming language, or they don't come from programming language background at all. They have never done any programming. So the goal of the Python refresher with AI for this program is basically to give you those fundamentals that you need within the Python programming itself to allow you to be able to understand and apply the concept that you're going to learn in this program. Then we got the generative AI literacy. Basically, that is to give you the introductory, concept, the fundamentals of AI. When we talk about AI, what exactly does it even mean? And there are a lot of nuances to AI. So this specific unit itself in this program is to give you that deep dive into what AI means and all different fundamentals that it needs. Then we are covering things like machine learning. Then basically we look at machine learning, what exactly different kind of machine learning, how do you build different ML application. And this units also, they have got a lot of hands-on units or classes that you'll take, where those hands-on classes gives you, more hands-on experience in building ML application. That goes for, then you got like your capstone project, where the capstone project will take a look at everything that you've learned during your program period. Then how do you build an application out of that? So you take all that knowledge, then come up with a project within the capstone project that takes all that into account, and you build an application out of it that you could be able to showcase maybe for your in your portfolio, or maybe in your LinkedIn profile or in your portfolio. And then so it's not just a question of building something to show for your portfolio, but again to give you the hands-on knowledge that you do need.
Great, thank you so much, Kennedy. Before moving on to the next slide, just wanted to let everyone know that there are a lot of questions that have come our way. This is a live session. There's someone asking whether this is a live session because they've been trying to get answer to their questions. Please do note that we have a Q&A segment planned at the end of it. So we will try to answer as much questions as possible. But considering that we are already we have taken 1 hour of your time, we want to keep the next slides very short and maybe take just 3 to 4 questions. So I'll quickly move on to the next one. So like Kennedy had mentioned, knowing just theory is not enough. The company hirings right now want people who have actually built things, and that's why this program includes more than 10 industry projects. You are not just like watching someone else code, but you would be building a computer vision model yourself. You would be creating an AI powered HR assistant. You are deploying a chatbot. You're working with real data to solve real problems across different industries like healthcare, finance, retail, and autonomous systems. So by the time you complete this, you'll have an AI portfolio that speaks for itself. And the skills and tools covered in this program are plenty and very, very relevant in today's competitive job market, like prompt engineering, agentic AI, ML model training, large language models, and NLP, and all of these things. This is the stack that AI practitioners need to be fluent in right now. And like you can see on this slide, there are like 15 plus tools also that this program will cover. So beyond the curriculum, Simplilearn supports your career transition end to end. Interview prep, resume and profile optimization, curated job opportunities matched to your skill set. And let me tell you, this is not a common offering by other learning platforms. There might be a lot of surface level job guarantees or raise guarantees, but you need to deep dive and look at what exactly they're offering you to back that guarantee. And that's where Simplilearn's commitment to your learning outcome after the program comes in and really stands out. So, right. So, for those of you who are interested in enrolling, here is the terms of investment. The program fee is at 2,79,989 for learners from India, whereas for learners from the USA, it is at $4,300. We have tried to make this as accessible as possible. So for learners in India, you're looking at EMI options starting from under 13,000 rupees a month. And for US learners, under $430 a month. So for our audiences from other parts of the world, let me take a moment to quickly share the program link on the chat. Yes, so you can get the exact fee in your local currency on our program page. Please do check this out. We apologize for not being able to present all the currencies in the slide currently. So just to recap, here is what this investment will include: 200 plus live hours of live online sessions led by industry experts, 12 plus hands-on projects, including 3 capstones across various industries, exposure to 15 plus tools like ChatGPT, Claude, Descripit, Julius, Zapier, and Python. Exclusive access to hackathons and Ask Me Anything sessions hosted by IBM. Session recordings 24/7 on Simplilearn's LMS for a flexible learning experience. A dedicated cohort manager for all your queries and help you succeed, who would help you succeed at every learning step. And most importantly, the Simplilearn career services that I just spoke about. Right, so for those of you interested in enrolling, I am going to launch a poll to take your answer. You can just simply click on yes or no to let us know if you would be interested. If you want to learn more, if you want to take some time to discuss side, if you have more queries, please do click on yes. Our expert advisor will be getting in touch with you to, guide you further. And if you are voting no, feel free to let us know why in the chat. We would genuinely like to understand what's holding you back and how we can serve you better. And also, you can use the QR code on this screen to download the curriculum or know more about the program. So while we have the poll live, Kennedy, I think we can take maybe 4 to 5 questions if we are, a little quick about it. I don't want to keep everyone waiting and you waiting as well. So we can just quickly take a few questions. Okay, so these SLMs, are they similar to the tools that we used to build in our olden days to perform specific tasks? So is it like, Canva, Notebook LM? I saw these specific references as well. So I think people, participants want to know what really like SLM tools are like. Kennedy can't hear you. I think you are still on mute.
Oh, okay. Yeah, sorry. Sorry, you asked a question there. You were mentioning that is the question regarding you mentioned Notebook LM and some other things.
Canva.
Canva. Okay, so what is the question?
Are SLMs like that? Like, are SLMs like these tools? Is what the question was.
Okay, so depending on which specific maybe tool or that you're looking at and what exactly an SLM is, what a small language model. Yes, there could be, when it comes to the implementation, it depends on, it doesn't mean there is a match on one-to-one on the tools that we talked about, that all these tools are SLM. But I'm saying in terms of when it comes to the implementation itself, depending on what specific use case and what is it that you're building, you could be able to have an small language model as an implementation of that. But it doesn't mean like when we talk about all these other tools, that you even mentioned on the slide there, that all those tools are a match to one-to-one onto what a small language model is.
Okay. Right. So moving on, why should we use SLM when we can, use agents, AI agents?
So why would you use so remember an agent, what exactly is an agent? So an agent consists of different things. One of the things that an agent consists of is a model. It consists of tools. It consists of things like scales. It consists of different things like memory and all those other things. So it means you could have an agent, and that agent, instead of using a large language model, your agent could use even either a small language model and even a large language model, or even only small language model. It depends. So an agent is not a replace. An agent consists of a model, and that model could either be a large language model or a small language model, or even a combination. It just depends on, you could have an agent which is a multi-agentic system that you got different models. You got small and large language model, just depending on what is the sub-agent within your multi-agentic system is doing.
Mhm. Okay. Can you define 30 to 14 point precision? I'm not sure. I'm not technically, knowledgeable enough to understand if this is relevant to SLM, topic, but you can take a call on whether we need to address that question.
Yeah, so in general, when in training of the large language model, they are trained on like 32 floating point, like precision in terms of the weight. So there is the concept of the weight. I'm not sure if the person asking is familiar with the weights. So there's the concept of the model weight itself. Then the model weights in terms of the precision. When you train these models, they come trained in 32 floating points precision itself for the model weight. You could be able to, let's say you got that model and you want to kind of use it for like on edge device, for example, then you need to have a lower representation, precision representation of that. Then you do a thing, you do like a quantization, model quantization. So the quantization is what I mentioned, is where you could take like a large language model trained on 32 floating point precision on the model weight, then you quantize it. There are different types of quantization. Again, I'm not going to go into the solutioning on how you do that right now. But again, the quantization itself, you'll take that 32 floating point precision and then quantize it to maybe like int 8 or int 4 if you really want to go that far, representation of the model weight itself. Then that allows that model to, in terms of the memory usage itself, is going to be much more less, which allows you now to use that model for maybe like on edge use cases.
Mhm. Okay, thank you for that, Kennedy. Last question that we will take is from Anubal. How is sensitive data protected when tasks move locally, move between local SLMs and the cloud-based LLMs? How is sensitive data protected? Number one. Number two, do you think hybrid AI will become the standard architecture for future enterprise?
Yeah, so interesting question. So if I take the first one, so again, when we talk about using a small language model that you are able to, operationalize within your local infrastructure itself, yes, there are a lot of nuances and the things that you need to do to make sure that data is secure. But at the same time, comparatively, if the data is not really leaving your infrastructure, compared to data that perhaps you need to share somewhere, maybe send this data to a large language model somewhere or something like that, or a large language model get access to this data. That exposes in terms of just the security risk that comes with that is comparatively higher compared to if you are to take a small language model that you are managing and running on your local system itself. So the advantage here comes in the sense that a model that you're running on your system, on your local system, it's much more easier in terms of how the blast radius in terms of the security exposure that it has compared to one which you are not the one really managing and controlling. The second question was with regards to, again, remind me the second question. The second part of that question.
Is hybrid going to be, the future architecture, future standard architecture in all enterprises?
Again, I'm not going to overgeneralize and say it's going to be for all enterprises. It just depends on exactly what is it your business model and what exactly is it that you're doing. But it makes more sense to take like an hybrid model, sort of like approach, because with a hybrid model, you use choosing the right kind of model for the right specific use case or the specific task. And in terms of which one is more optimal and making sense, then the hybrid model make more sense because for a use case where for a task that you just need a small model, there is no need for an overkill and use a very powerful, expensive model for it. So the hybrid model makes a lot of sense, and I do see like there could be a lot of traction in terms of the adoption of hybrid model.
Okay, perfect. So with that, I will also end the poll to, show your interest in enrolling in the program. So we have a very, very exciting webinar that is coming on the 17th of May. It is from 7 to 10 p.m. IST and 9:30 a.m. to 12:30 p.m. ET. It is going to be a live 3-hour workshop where we're going to use Claude to code, and we're going to build very interesting multi-tool workspace. So it's going to be a really interesting session, and it is planned in a way that it is very beginner friendly. It is for non-coders as well. So it's going to be led by one of our other trainers, an AI engineer, Timothy Henny. So please, you can scan this QR and register for the webinar, or let me share the link as well for everyone wanting to register for the webinar. Great. Okay, so with that, I am going to launch another poll where you can enter your full name. We will be able to generate the certificate and share with you within 48 working hours. Just give me a second. Yes, the poll is live. Please drop your full name, the name that you want on the certificate, to how you want it to appear in the certificate. We will generate the certificate and share it with you on email. In case you're not able to access the poll, or if there's any issue, please feel free to write to us at webinars@simplilearn.net, and we will look into that. Okay, so with that, we're coming to the end of the session. To all the participants, thank you very, very much for spending the last 1 hour with us. We hope that you'll be able to apply the learnings from the session, as well as what you will get from our professional certificate in AI ML to get ahead in your career. We know that we were not able to address specific use cases, because this session was about introducing you to the concept of SLM, and giving you a framework which you can use to make the decision. So yes, if there is anything else that you want us to do webinars on, or any questions that you have, please do write to us at webinars@simplilearn.net. We would love to hear from you any feedback that you have as well. Kennedy, thank you so much for your guidance and sharing your insights and knowledge. It's been an absolute pleasure hosting you. Do you have any final remarks to share, any advice for our learners before we wrap this session?
Yeah, so I think my closing remark here would be the industry, for those who are in the industry or are interested in the industry, it is a very dynamic and interesting industry. And there's just a lot that you could be able to do with this, with this technology. And I would encourage you all to explore how you can leverage either what you are currently doing in whatever role you are in, and how can you be able to leverage AI in order to get better at doing whatever it is that you do. So that's been all from me. Thank you all for finding time for joining to this webinar. Thank you.
Yes, thank you so much once again, everyone. With those wise words, I am ending the session. Thank you.